Welcome to this video tutorial. This video tutorial discusses the Berry ratio in a case of what we call the example of the oil distributor example. In a previous tutorial, we discussed when to use the Berry ratio. And one of the cases that we discussed was when the COGS of the distributor are highly variable over time, the Berry ratio may be an appropriate PLI for measuring the return for that particular distributor without it being overly distorted by movements in, say, a commodity price of the product that they're distributing. How might this work? Well, imagine a commodity price, say for example in this case commodity fuel. You can see the huge swings that can happen in a short-term basis with this kind of price running up and coming back down. And if you're a distributor of this, your revenues could be shooting up and down even though the quantities of what you're selling at any given point in time may be relatively flat. In many of these cases, distributors who operate in this type of business collect a fee based upon the number of units that they sell, say the barrels of oil, as opposed to the actual dollar value of those barrels of oil in the marketplace at any given moment in time, to prevent this problem of their revenues swinging up and down so radically. They've essentially transferred price risk back to the manufacturer, and they're really providing a service of distribution and compensated for that function of buying them and selling them, but without recording the huge swings that would come about in profits from the price going up and down. So let's look at how this would operate. And a simple example, we're going to start off with a distributor who is selling 1,000 barrels of oil at $50 per barrel and bringing in a revenue of $50,000. They're going to be paid a placement fee equal to $10 per barrel, so that'll be $10,000, and they're going to remit back the difference to the oil producer, the remaining $40,000 that'll be reflected as their COGS. This will leave them with a gross profit, which will be equal to their placement fee of the $10,000. They have an operating expense of $8,000, and so the operating profit will be $2,000. Now, if you calculate the operating margin, you'll get a number of 4%, the $2,000 of operating profit over the revenues of $50,000. And the Berry ratio, which would be the gross profit of $10,000 divided by the operating expense of $8,000, will be 1.25. Now let's take this example and work through what happens as the price of oil goes up and down. As you can see in this table, we have the exact same number of barrels sold in every period, 1,000 barrels. And because of that, the placement fee per barrel is being held at $10 per barrel, so the placement fee would be the same $10,000 in every period. But we start off this cycle with the price of oil being $50 per barrel, going up to $100 per barrel, and then back down to $50 per barrel, which is not an unrealistic experience in the oil industry. So when we calculate out the profit level indicators in these two cases, in our column where we have the placement fee, which is effectively the gross profit, divided by the cost of the placement agent, which is our operating expense, we see that in all 5 periods being measured here, our measure is a constant 1.25, and that's our Berry ratio. But if we look at the placement fee less the cost of the placement agent divided by sales, so we're looking at the operating profit divided by the sales level, that number starts at 4%, drops down to 2%, goes back up to 4%. As the price of oil goes up and down, the operating margin goes down and back up. The movement might be enough to drive a tested party out of the range, but the Berry ratio stays steady regardless of the movement in the price of oil. Thank you and have a great day.